Hello, friends of Sudoku. Well, welcome to an extreme puzzle by one of the apps on my phone. I haven't solved this one yet, but I was spending a few minutes in a coffee shop on top of one of Vietnam's most iconic mountain passes. It was raining and it was foggy, and we couldn't see more than 50 meters ahead of us on the motorcycle, so it wasn't safe. So I did a screen dump of this puzzle, and now I'm going to try to solve it without using pencil marks. But before I do that, it has come to my attention that there are some players out there who solve Sudokus by looking at each row or column in isolation. And to me, at least, that is not necessarily the most efficient way to solve a Sudoku puzzle. There is a reason that we have a chute or a rank here of three by three boxes. We have the first, the second, and the third rank. We also have three files. This is one file, this is one file, and this is one file. And each file also consists of a group of three columns. And these act in some kind of a symbiosis because, as we know, we need to have 9 distinct digits in each row and column, but also in each 3 by 3 box. And that is the reason that when we look at a puzzle like this, and let's say I look at these top 3 rows, I always look at 3 rows or 3 columns together because it's much quicker and much more efficient than looking at one single row. So if you're a beginner puzzler, you might want to look at this top row and say, okay, I've got a 1 and a 3. Let's see, where can I put a 2, 4, 5, 6, and so on. And that's not really, I think, the best way to go about it. What I do is this. I look at this entire block of 3 by 3 by 3 boxes, and then I look across, and I immediately see that there's a 2, 6, and a 7 here. Those 2, 6, and a 7s have to go in one of these 4 cells here because they cannot be repeated inside of this cell here because they're already present in the box, right? So in order to have a 2, 6, and a 7 at all in the top row, they need to go here, 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 and here, or at least in 3 of those 4 cells. So to me, it's much quicker to look and say to myself, where can I put a 2, 6, and a 7 in the top row? Because I have 3 digits and I have 4 empty cells. So maybe something will appear and be clear to me. And in this case, it is true because I also have a 2 and a 7 here. So we have a 2 and a 7 covering both of rows 2 and 3. I need to find places for a 2 and a 7 in row 1. And it's clear because they are already present here that none of these cells here can contain a 2 and or a 7. And that leaves only these 2 cells. They have to be a 2 and a 7 now. That doesn't tell me if the 2 goes here or here, but it tells me that I have to look elsewhere now for other digits. For example, the 9 now will have to go in one of these 3 cells because there are no other empty cells in the top row for a 9 because these 2 will have to contain a 2 and a 7. And then I continue. Let's look at the ones here. This one blocks these cells. This one blocks these cells. Therefore, this cell must be a 1. And now I immediately scan right. Again, I have a group of 3 rows here, rows 1, 2, and 3. And rows 1 and 3 already have a 1 in them now, so I don't have to concern myself with a 1 for these 2 rows anymore. But I am going to look now for a 1 in this row here. And since a 1 can't go here, 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 or here because of this 1, and this 1, there's only 1 cell left for a 1. And once I enter this one, I immediately scan downwards and I look at this one here, blocking these cells, and this one blocking these cells, and here's the one for box 9. Now I go back and I look at these two cells. They block these cells here, and the one up here blocks this one. This is now a 1. And the last one for this grid is going to be down here because of the one here and here blocking these cells, and the one here blocking this. So this is basically how I go about solving the first steps of any puzzle. It's usually quite easy to find givens for the first, let's say, 15 or 20 digits, and then it might get a little tougher. One thing that appears very obvious to me is that there's a 7 here and there's a 7 here, and they block these cells, don't they? And the 7 here blocks this cell. Therefore, this must be a 7. And I know that this 7 blocks this cell and this cell. This 7 blocks these 3 cells. Therefore, a 7 for this row must go either here or here. I don't know where it's going to go, but I know that a ghost 7 here and this 7 puts a 7 in one of these 3 cells up here because we still need a 7 for row 4. But this 7 and this 7 block these 2 cells. Therefore, the only place a 7 can go in row 4 is here. Now we just need 2 7s, and I can't place them yet, namely a 7 for one of these 2 cells and a 7 for one of these 2 cells. Another pattern that I really love about Sudokus is the 3 here blocking these 3 cells. So now I know that a 3 for the center column will have to go either here or here. And while I don't know which cell it's going to end up in, I know that now that a 3 can't go here, besides there's a 3 over here, right? And a 3 can't go here or here either. But what does that do for me? Well, it does this for me, that this 3 also blocks this cell. So now I know that a 3 for this row, row 9, will have to go either here or here, right? So a ghost 3 here and a 3 here leaves only this cell for a 3 in row 8 because there's a 3 up here blocking this cell, right? So this is where the 3 must go. So quite often we can find a digit by knowing where other digits can't go. So a 3 here and a 3 here block these cells. This 3 blocks this cell, and therefore this must be a 3. And now we know that this cell is going to be a 3. Remember, it had to be one of these 2 cells, right? And now it can't go here because of the 3 we just found. Another thing that I like to do is, once I know that these 2 cells will have a 2 and a 7 in them, I ask myself, well, what about these 4 cells here? If these 2 have to be a 2 and a 7, there's a 6 here blocking these 2 cells, and there's a 6 here blocking this cell, so this cell must be a 6. Now we need to find 8, 9, and a 4. And this 8 here blocks these 2 cells. These 2 still can't be an 8 because they have to be a 2 and a 7, so this is an 8. And these 2 now have to be a 4 and a 9. And there's a 9 in the row. So that puts a 9 here and a 4 here. And now we know that we have a 9, 4 here. And we know that one of these will have to be a 4 because this cell must be a 5 or an 8 along with this one here, right? And we also know that a 9 will have to go up here. I don't know where to put them yet, but now I know, and I don't have to analyze that further. I know that one of these 2 cells will have to be a 2 for the simple reason that all other cells are already occupied in this column. I also will have to find a 4 for one of these three cells, and the last digit that would have to go in here is going to be a 5, and the 5 will have to go here or here because of this 5 here. So while I don't know what to do with these three cells right now, I know that the remaining three cells here, these being a 4, 5, and a 2, they will have to be a 6, 7, and a 9, won't they? And there's a 6 here and a 9 here, so that makes this a 7. And that now resolves the 7 and the 2 we had up here, doesn't it? These two cells now have to be a 6 and a 9. And while I think about the ramifications, this cell now becomes a 5. These two have to be a 2, 4, and an 8, and there's nothing I can do about that right now. And at this point, I usually start to just count because it's easier. I count the three empty cells here, and I can see that they need to be 5, 6, and an 8. And then I look at the rows and I see the 5 here and the 6 here. That automatically makes this an 8. And now we need a 5 and a 6 for these two. This cannot be a 5 because of the 5 here, right? So that's got to be a 6 and this is going to be a 5. These two 5s now puts a 5 in this cell. The remaining two have to be a 4 and a 2 as we recall, and there's a 2 already in the row here. So this is a 4 and this is a 2. This 2 and this 2 and this 2 puts a 2 here. And one of these, as I recall, had to be a 6, didn't it? This one can't be a 6 now because of the 6 in the row. So this is a 6, and the last one's got to be a 9. We can resolve the 5 and an 8 pair here easily, but we have to do it in a little circumvent way. Look at the 8 here. It blocks these two cells. Therefore, an 8 for this column must go here or here. That's, I think, indisputable. So if an 8 has to go in one of these two cells, it follows that it can't go here as well. Therefore, this must be a 5 and this must be an 8. These three cells have to be a 4, 5, and a 9 now. There's a 5 here and a 4 here, making this a 9. And these two cells, if these have to be a 4 and a 5, the last two missing here is going to be an 8 and a 6. But remember the ghost 8 we had here? Apart from preventing an 8 from going in this cell, it also prevents an 8 from going in this cell. Therefore, it has got to go here, and that makes this a 6. This last digit now must be a 4, of course. We got a 4 here and here, and that puts a 4 in this cell. This is now a 2 and an 8. And the last cell here is going to be a 2, of course. I almost overlooked that one. A 5, 6, and a 9 for these three cells. There's a 6 here blocking this cell. There's a 6 here blocking this cell. Therefore, this must be a 6. And this is now a 5 or a 9, and this is a 5 or a 9. But there's a 5 in this row. Therefore, this must be a 9, and this down here must be a 5. Now we got this 9, and we got this 9, and we got this 9, and they block all of these three cells. Therefore, this must be a 9. And that makes this a 9, and this as well. This last digit is a 2, making this a 2, and this is an 8, making this an 8, and this, and this. This last digit at the bottom has got to be a 3, and that makes this a 5. And that takes care of the 5 and the 4 we had going on over here, and this is now a 4, making this a 4, and this is going to be a 3. This last digit is going to be a 3 as well. Some of you will object and say that this was too easy. And I would agree, it's easy enough if you know how to do it. But if you're a beginner or intermediate, solver, then you might find some of these hints and tips useful for your own games. In any event, I hope you enjoyed it and that you will come back for more soon. Thank you for watching and bye for now.